Hello, my name is Kainton Genius, and today we are going to be talking about application of Bayes theory, and this will be lesson 10 of our Machine Learning 101 lecture series. And today we'll see how Bayes theory actually works in practical terms. I'd like to remind you to subscribe to my channel by clicking on the subscribe button below this video. And if you have any challenge following this course, because this course is meant for everyone, so if you have any challenge following it, please let me know by leaving a comment for me in the comment box below, and be sure that I'm going to respond to you as soon as possible. So let's see how we can apply Bayes theory. The first thing I'd like to advise you to do is to learn that you already know how to write Bayes theory. And before I write it, let's just do a quick recap about the sum rule, the product rule, the marginal probability, conditional, and joint probability. The sum rule helps us to find marginal probability, and we also have that the product rule helps us to find joint probability, whereas Bayes theory gives us a formula for conditional probability. When we write all these things on the board, it becomes very, very clear. So let's start with, first I'm going to write Bayes theory so that it becomes fresh in our mind. Bayes theory says that probability of x given y is equal to probability of y given x times the probability of x all over the probability of y. So basically this is Bayes theory. Now let's now apply it in the case of choosing items from the blue box and the red box. Let's see how it actually plays out. So let's start by specifying the marginal probability of selecting a red box or a blue box. So from an experiment that was carried out, the marginal probability that a blue box will be selected is 6 over 10, and the marginal probability that a red box is selected is 4 over 10. So after now, maybe I will not be using the word marginal, I'll simply use probability. So in this case, we have probability that a red box is selected is 4 over 10, and the probability that a blue box is selected is 6 over 10. Alright, so let's see. So in terms of conditional probability, let's now write different conditional probability. For instance, probability that when a fruit is selected, it is an apple, given that the box is red. So let's take, for instance, the first one. We have probability that the fruit is an apple, given that the box is equal to red. This will now be the probability of a fruit being selected from the red box, and that will be 6. An apple is selected from the red box. That will be 6 over 8, which is actually 3 over 4. I have to write on top here. Probability that a fruit is an orange, given that the box is red. You can work this out. So it will be fraction of oranges in the red box is equal to 1 over 4. It's very clear. Let's now move to the blue box. Probability that a fruit selected is an orange, given that the box is blue. In that case, we have 1 over 4. And the probability that a fruit selected is an apple, given that the box is blue, is 3 over 4. Number of apples in the blue box. Alright, let's now go to a particular problem. In this case, the problem is, what is the overall probability of choosing an apple? What is the overall probability? In this case, choosing an apple from both boxes. That is the marginal probability or overall probability. Now we are not told anything about whether it's from the blue box or from the red box. Now to find the overall probability of choosing an apple, you simply check how many ways can we choose an apple. The first way is that we can actually select the red box and choose an apple from it, or we can select a blue box and choose an apple from it. So we can say is the sum of the joint probabilities of choosing an apple from the red box and choosing an apple from the blue box. So I'm going to write down this summation because it's very important. So the probability that the fruit is an apple will be equal to the probability that the fruit is an apple where the box is blue plus probability that the fruit is an apple and the box is red. Okay, now we have two joint probabilities here. We can find joint probability using the product rule. So we can say that probability that the fruit is an apple and the box is blue. What does it mean? We now use the sum rule, and this will give us the fact to be the same as probability. This time the joint probability is equal to the product of the conditional probability and the marginal probability. So take note of all these things. So this will be probability of selecting an apple given that the box is blue times probability that the box is blue. Okay, so this is just the sum rule I'm stating it here. So if this probability f is equal to a and b is equal to b, it should be the last one, which is 3 over 4 times probability that the box is blue is this, which is 6 over 10. So if we work it out, it will have 9 over 20, right? Good. And the second way, probability, this one, now we are on this one. Probability that the fruit is an apple and the box is red. Now by the product rule, we can just write it out as is equal to the conditional probability that the fruit is an apple and the box is red times the probability that the box is red. So this conditional probability here should be equivalent to this. So that will be 3 over 4. I hope I'm not mistaken. Okay, 3 over 4 times 4 over 10. And that will give us what? 3 over 10. So this probability P that the fruit is equal to apple, which is the marginal probability, will simply be gotten by summing this and this, which we already have, which is 9 over 20 plus 3 over 10, which eventually will give us 3 over 4. So let's see. So that will give us, if we work it out, we pick a pen again. Work it out, we have 15 over 20, which will give us 3 over 4. Now we played around with conditional probability, joint probability, and marginal probability. Why does Bayes' rule now come into play? Now see the question here. It says, what if the fruit is picked and it turns out to be an orange? What is the probability that it came from the blue box? If fruit is picked and it turns out to be an orange, what is the probability that it came from the blue box? So in that case, let me just move to the next page so that we can write everything clearly. So we are saying that probability that a fruit is picked and it turned out to be an orange, what is the probability that it came from the blue box? Alright, so let's write Bayes' theory, probability that the box is blue, given that the fruit is an orange. So this is the probability we are trying to find. Probability that the fruit is an orange but it comes from the blue box. What is this probability? So if we write this in terms of Bayes' theory, it will have that this will be equivalent to probability that the fruit is an orange given that the box is blue times the probability that the box is blue all over what? probability that the fruit is an orange. So basically, this is what the question is telling you. Probability that, for instance, if something is picked up, let's say I pick up this candy from this box and it turns out to be white. Now I'm keeping back this candy. Somebody that didn't see when I picked it up comes and say, okay, what is the probability that the white candy was actually picked from the blue box? So we are trying to find out a probability, something that is called posterior probability, but we are going to talk about it a little later. So in this case, we can just substitute all the values we have. So probability that the fruit is an orange given that the box is blue. Probability that the fruit is an orange given that the box is blue, which is this, which is 1 over 4. That will be 1 over 4 times probability that the box is blue should be 4 over 10, should be 6 over 10, all over probability that the fruit is an orange. Okay, in this case we have the fruit is an apple. So let me just make a little change. So now I'm going to leave out the one of orange for you to work out. So probability that the fruit is an apple, we calculated it to be 3 over 4 as well. So if we work out this, we have 6 over 40 all over 3 over 4, which will give us 6 over 40 times 4 over 3, right? 6 over 40, yeah, times 4 over 3. So if we work out this will give us what? 2. And this will give us 10. So that will give us 2 over 10, which is 1 over 5. So this is what Bayes' theory helps us to find. The probability that the box is blue, but given that the fruit is an apple. Now I have little time left. There are exercises, and there's also a topic called prior and posterior probabilities. What does this times mean? Let's look at it in the next lesson, and that will be lesson 10a, because this is actually lesson 10. If this has been informative for you, please like this video and also leave me a comment to know how you feel.